yes and E be an event such that each outcome is equally likely, then probability of E is nothing but number of outcomes favorable to E divided by the total possible outcomes. Now, we need to discuss conditional probability, which is a very important concept of statistics, which is nothing but a measure of the probability of an event occurring where it is given that the another event has already occurred. Also, conditional probability comes when an outcome of a trial affects the outcomes of the subsequent trials. Now, we need to discuss conditional probability, which is a very important concept of statistics, which is nothing but a measure of the probability of an event occurring where it is given that the another event has already occurred. Also, conditional probability comes when an outcome of a trial affects the outcomes of the subsequent trials. Now, let us discuss the definition of conditional probability. It is the probability of an event occurring given that another event has already occurred. Consider two events A and B associated with the same sample space of a random experiment. The conditional probability of the event E given that F has already occurred, that is given by probability of E given F, which is nothing but probability of E intersection F upon probability of F, where the probability of F should not be equal to 0. Similarly, one can write the conditional probability of F given E, which is given by probability of E intersection F divided by P of E, that is the probability of E, where probability of E should not be equal to 0. Let us solve an example. Given that E and F are events such that probability of E is equal to 0.6, probability of F is equal to 0.3 and probability of E intersection F is given as 0.2. Find probability of E given F and find the probability of F given E. Let's see the solution. Given probability of E is equal to 0.6, probability of F is equal to 0.3. Also, the probability of E intersection F is given as 0.2. Next, we need to find the probability of E given F, which is given by the equation probability of E intersection F by P of F. Substituting the value, we get it as 0.2 by 0.3, which is equal to 2 by 3. Similarly, probability of F given E is given by probability of E intersection F divided by P of E, which is equal to 0.2 by 0.6, which is equal to 1 by 3. It's a direct substitution. Alright. Now, let's solve one more problem. If the probability of A is equal to 6 by 11, probability of B is equal to 5 by 11, and the probability of A union B is given as 7 by 11, not A intersection B. Then, we need to find P of A intersection B. Solution. First, write the given data. That is, P of A is given as 6 by 11, P of B, probability of B is given as 5 by 11 and probability of A union B is given as 7 by 11. Now, probability of A union B, we have one equation, that is P of A plus P of B minus P of A intersection B, which implies 7 by 11 is equal to 6 by 11 plus 5 by 11 minus P of A intersection B. Taking P of intersection B to the other side, we get it as 6 by 11 plus 5 by 11 minus 7 by 11, which is nothing but 4 by 11. Alright. Now, let us discuss the important properties of conditional probability. The very first property is that let E and F be the events of a sample space S of an experiment. So, the probability of S given F is given by probability of S intersection F divided by probability of F, which can again be written as P of F by P of F. The probability of S given F is equal to probability of S intersection F by probability of F, which is nothing but probability of F upon probability of F, which is equal to 1. Mark this equation as number 1. Similarly, probability of F given F, which is nothing but probability of F intersection F upon probability of F, which is equal to probability of F by probability of F, which is equal to 1. Mark it as equation number 2. Now, from equation 1 and 2, we have probability of S given F is equal to probability of F given F, which is equal to 1. Now comes to the second property. It states that if A and B are any two events of a sample space S and F is an event of S such that, now the second property is, if A and B are any two events of a sample space S and F is an event of F S such that probability of F is not equal to 0, then probability of A union B given F is equal to probability of A given F plus probability of B given F minus probability of A intersection B given F, which implies that P of A union B given F is equal to P of A intersection F by P of F plus P of B intersection F by P of F minus probability of A intersection B intersection F by P of F. We just have expanded, alright, which implies that P of A union B given F is equal to, this is nothing but P of A given F, this is nothing but P of B given F, and this is nothing but P of A intersection B given F. Now, let us discuss the third property of conditional probability. Since the probability of S given F is 1, which implies that P of E intersection E complement given F is equal to 1, because S is equal to E intersection E complement, which implies that P of E given F plus P of E complement given F, which is equal to 1. Therefore, P of E complement given F is nothing but 1 minus P of E given F, taking this to the other side. Okay. Now, let us discuss the multiplication theorem, which states that if E and F are two independent events associated with a sample space S, then the probability of simultaneous occurrence of the events E and F is given by P of E intersection F is equal to P of E into P of F given E, where the probability of E should not be equal to 0. Similarly, P of E intersection F is equal to P of F into P of E given F, where the probability of F should not be equal to 0. Let's discuss about the definition of independent events. If the probability of occurrence or non-occurrence of one of the event is not affected by the other, then we can say the two events are independent events. So, for any two independent events, E and F, we have the relation P of E intersection F is equal to P of E into P of F. P of F given F is equal to P of F, where P of F should not be equal to 0. And the third, P of E complement intersection F complement is given by P of E complement into P of F complement. Now, let us solve some questions given two independent events A and B such that the probability of A is given as 0.3 and the probability of B is given as 0.6. Find probability of first one A and B, second one probability of A but not B. Let's see the solution. Since A and B are independent events, Therefore, the probability of A and B is nothing but P of A intersection B, which is nothing but P of A into P of B. Substituting the value, we get it as 0.3 into 0.6 and we get it as 0.18. Now see the solution of the second part, that is P of A and not B, which is equal to P of A intersection not B means B complement, that is P dash, which is equal to P of A minus P of A intersection B. Substituting the value, we get it as 0.3 minus 0.18, which is equal to 0.12. Now let's see one more question. Two cards are drawn at random and without replacement from a pack of 52 playing cards. Find the probability that both the cards are black. Let's get into the solution. Since the number of exhaustive cases is equal to 52 and the number of black cards is equal to 26, one black card may be drawn in 26 ways. Therefore, the probability of getting a black card is equal to probability of A, which is equal to 26 by 52, which is equal to 1 by 2. Now, after drawing one card, the number of cards left is what? 51. And the number of black cards is 25. Therefore, the probability of getting both black cards is given by P of A into P of B given A, which is equal to 1 by 2 into 25 by 51 and we get it as 25 by 102. Alright, now let us see another question. A bag has 4 red and 3 blue balls. The second bag has 4 blue and 2 red balls. One bag is selected at random. Find the probability that the drawn ball is red. This type of questions can be solved using the theorem of total probability. That is completely based on the partition of the sample space and which we will be discussing in our next video. Now, let us wind up the entire section.
Manorama Horizon. Learning made simple.